Hello class, this is Miss Augustine. Today we are going to solve some heat problems. Okay, so the first problem we're going to solve is going to be solving for heat absorbed, so the variable is Q. So as always, identify variables. So the mass is our 43.0 grams, our T1 is 11.5 degrees, T2 is 71.2 degrees, and C for water, the specific heat, is 4.184 joules per gram degree C. So the equation that we use is Q equals M, mass, times C, specific heat, times delta T. And our delta T here turns out to be 59.7 degrees C. So Q is equal to our mass, which is our 43.0, and then our C is 4.184 joules per gram degree C, and our delta T, as I said previously, is 59.7 degrees C. Check units. Grams divided by grams cancels. Degree C divided by degree C cancels. So now all we have to do is go in and multiply. So Q ends up equaling 10,740.7464 joules. Now we have to look at sig figs. And it looks like we're rocking 3 sig figs, so we're going to look at our third significant digit here, which is a 7. Number after it is a 4, so we don't have to round up, we leave it alone. So our Q then is going to be 10,700 joules, and we'll put a box around it so the world knows. Problem 2 is going to have us solving for specific heat capacity, which is C. So identifying variables, our mass is 55.8 grams. Our Q is 7,500 joules. Our T1 is 25 and our T2 is 75.5, which gives us a delta T of 50.5 degrees C. So now, rearranging our equation, C is equal to Q over M times delta T, which is equal to, plugging in the numbers, 7,500 joules divided by our mass, which is 55.8, and our delta T, which is 50.5 degrees C. So C turns out being equal to 2.661555648 joules per gram degree C. And even though that's what the calculator says, we know better. We know that we should be rounding this to 2 significant digits because of our number of joules. So 2 significant digits would end right there. The number immediately following is a 6, which means we're going to have to round up. So to 2 significant digits, our heat capacity C is 2.7 joules per gram degree C, and we'll put a cute little box around it. Good. For problem C, we're going to be solving for mass. So always starting the same way, identify variables. So in this case, C is 3.64 joules per gram degree C. Our Q is 4,500. And our delta T is 35 degrees C. So now, let's rearrange our equation. So if Q equals mc delta T, C is equal to Q over m delta T, which is equal to 4,500 joules divided by our wait. Problem 3 is going to have us solve for mass. So identify variables. Oh, hang on. Problem 3 is going to have us solve for mass. So we'll start with identifying variables. C equals 3.64 joules per gram degree C. Delta T is 35 degrees C. And Q is 4,500 joules. And if our equation is Q equals mc delta T, if we rearrange to solve for m is equal to Q over C delta T, which is equal to our 4,500 joules divided by our 3.64 joules per gram degree C times our delta T, which is 35 degrees C. So degrees C cancels, joules cancels, and 1 over grams is going to be grams. So our mass turns out to be equal to 35, and we plug it into our calculator, 35.3218, I love calculators, 2104 grams. That's way too many significant digits. Looking up at our delta T and our Q, we see that we have two significant figures, which means we have to look at the second one, counting from the left. That's our 35. The number immediately following it is a 3. The rule is 4 and below, we let it go. So our mass is going to round to 35 grams, and we'll put our little box around it. Our fourth and final problem is going to be solving for delta T. So again, identify variables. M is 72.6 grams. Our C is 6.89 joules per gram degree C. And our Q is 8750 joules. Now the first thing we have to do is solve for delta T. So rearranging our equation, delta T is equal to Q over m times C, which is going to be equal to 8,750 joules divided by our mass, which is 72.6 grams, and our C, which is 6.89 joules per gram degree C. So joules cancels, grams cancels, and 1 over C is going to be degrees C, and that's going to be 17.49 degrees C. We need to round that to 3 significant digits, so our delta T is going to be 17.5 degrees C. Now recall that our T1 was 31.4 degrees C, and delta T is equal to T2 minus T1, which means that delta T plus T1 is going to be equal to 2, so our T2 ends up being 31.4 plus 17.5, which comes out to 48.9 degrees C. And the rule for addition is we have to round it to the same place as the number with the fewest decimals, and all of the numbers involved are to the tenths place, so we leave our answer right where it is at the tenths place. And that is all for problem solving with heat for today.